Hi, my name is Tyler Hoover, and I will be showing you an overview of a project of a Nerf gun FireFly that I am modeling on a three-dimensional modeling program, SolidWorks. You can see here the 9 parts that I've completed thus far, and that I have titled each the shell, trigger, revolver pinion, cocking block, revolver barrel, plunger, plunger casing, plunger shaft, and plunger cap. The intent of the project was to create a minimum of 8 parts to exact of a dimension as possible of the Nerf FireFly. The end intent is to have every component modeled so that a working assembly may be created for stress analysis, possible component failures, and identify cost-reducing modifications for future modifications and marketing of the product. In order to achieve this end goal, the current goal is to modify existing parts to the best of my ability. In order to do this, all dimensions were taken using a vernier caliper that is precise to the thousandths of an inch. Part of my discussion of each part will include the process of modeling the part, how this design technique was related to the classroom techniques taught in Penn State's Engineering Design 496A, and any difficulties or software limitations included in the modeling each part. First to consider is the FireFly shell. It not only consists of the most features, but also included the most time, consideration, and difficulties. In order to begin the shell, I broke it into 4 main levels. First was the shoulder stock and main body, second the hand grip, and third the barrel, and lastly the finer details. It was in the general order I went about designing the part. Each level began with a general sketch based on the right plane. This allowed quick updates and alterations to be made. Once extruded, other features such as revolve, cut extrude, ribs, circular patterns, and loft were used to produce finer details, and finally the mirror feature to take advantage of the symmetry and mirror the right shell about the right plane to reproduce an identical body. Using the mirror feature reduced modeling time by half for the shell alone. The hand grip is a bit off from reality as it was designed to ergonomically fit the hand, but I had a lot of difficulty and limited time to reproduce the converging hand grip. Difficulties encountered in producing the shell were mostly encountered due to my lack of foresight of the sketch relations. I sketched a lot of on-edge relations, which are fine until you want to make alterations. Because many of my sketches referenced existing geometry, if I altered or eliminated existing geometry, there were many errors that required significant reworking. Also, of even greater concern, I modeled the shell exterior planning to use the shell feature at the end to gut the part and be left with a ½ inch thick surface. However, the finer details caused very small geometrical radii that could not be properly shelled. Upon eliminating these tight geometry, I still received the same errors. I was unable to work around this problem, so this will be an area of focus in the project as I move forward with modeling. If I am unable to shell the shell, I will have to use strategically placed extruded cuts to make room for the assembly of the internal parts. However, this will not allow proper stress modeling for the final project goals. Once the shell was completed, I could take a sigh of relief as it was the most difficult to replicate. The next part is the cocking block. This is the piece that translates the hand motion into the internals, pulling the plunger into place and putting tension into the spring. Similar to the shell, as all sketches were defined with relation to the right plane. Only half was modeled and then mirrored to take advantage of symmetry. A place of possible redesign is the strength of the long, thin part. This is connected to an internal spring, and there is significant stress built in this area. It has snapped already during my disassembly and will be a potential area of further focus in a redesign. The trigger also utilized symmetry about the right plane. Half the trigger was drawn on the right plane, and after all features were incorporated, the body was mirrored about the right plane. The trigger incorporated the slot tool, the shell feature, and thin extrusions. The revolver pinion allows an axis for the barrel to revolve about. The most noticeable features of the pinion are the shell and rib features. When extruding the square, shelled end section, it was not merged with the rest of the model, so it could be shelled separately from the other sections. Doing so reduced sketches if it otherwise had to be merged. The barrel, capable of holding 8 darts and rotates about the pinion, was the next most complex part. The front face was first modeled, and then all other features were extruded upward from that face. It also includes shelling and ribs on the inside of the front face. Using the circular pattern function greatly reduced work and simplified the sketch. By drawing a singular barrel shaft it could then be patterned about the central axis 8 times. This allows quick and easy modifications. In order to design the plunger stem and plunger, they were designed as a singular piece but not merged. This allowed easy relations to be built into the components and quick future updates. This useful means of modeling assembly pieces was not discovered until this piece, otherwise it would have been utilized in a large majority of all the components. Once completed, the plunger and shaft were separated into individual parts, as seen here. Similar to the plunger and shaft, the plunger casing and end cap also utilize the non-merging extrude feature to create dependent relations and quick updates. It is in the plunger casing that air pressure will build and exit from the end cap into the barrel to propel the dart. It was made quite easily with the extrude feature and building upward from the central chamber. Symmetry was not able to be used in this part because the features did not mirror one another, but were mostly off a common axis. This concludes the parts of the Nerf FireFly model thus far. Looking forward to the end design stage, it is evident that on-edge sketch relations should be avoided at all costs to simplify the updating process. Also, since tolerances will be of great concern to the assembly process with the many dependent components, it would be wise to build the assembly as a single part and create the parts as unmerged components. This would allow a streamlined updating process rather than a flipping between several components. Once all components are modeled, they will be assembled into a working model. From here, any redesign and potential improvements may be identified. This is Tyler Hoover. Thanks for hearing me out.